The facts are simple but impressive. Of the nearly 6.5 million kilometers of highways, roads, and streets in the U.S., about 2 of every 5 are unpaved and carry over 1/5 of all traffic. Most of these unpaved roads are aggregate surfaced, that is, covered with a layer of gravel. Although you won't find any gravel roads in our interstate system, you will find them making up a large part of our local roadway networks nationwide. And while gravel roads generally carry low volumes of traffic for short trips, they nevertheless are used for a wide variety of purposes, and sometimes by very heavy vehicles. Because they are essential to the local transportation of people and products, gravel roads need to be maintained in good condition. Their users deserve a safe and reasonably comfortable ride. In reality, though, conditions are not always good, and the ride's not always safe nor comfortable. The reason? Scarcity of road maintenance funds? Yes, in part. But there's always a shortage of public works money. Beyond the dollars, many local agencies also lack an understanding of the causes of gravel road problems and are unaware of the proper methods for preventing or correcting them. Then there's the ever-increasing abuse we heap on our gravel roads. Some of the stupendous wheel loads inflicted on them nowadays would be illegal on even our sturdiest pavements. This video presentation was produced as part of the Local Technical Assistance Program of the Federal Highway Administration. Its objective is to help local agencies recognize common problems of gravel roads, understand their causes, and learn how to prevent or correct them. A handbook has also been developed as part of this training course. The video is in 3 parts to allow an opportunity for discussion after each segment. In this first part, we'll examine the environment of gravel roads and the aggregate materials used to surface them. In part 2, we'll focus on the common problems of gravel roads, what causes them, and how to prevent or correct them. Then, in part 3, we'll look more closely at maintenance equipment and techniques. Now, just what is a good gravel road? Well, those who get the angry phone calls from upset citizens might describe it as one that doesn't have ruts, potholes, or loose gravel, one that drains well and isn't dusty, one that's smooth but never slippery. Of course, it also must be wide enough for vehicles to pass without driving into the ditches, not too steep, and not too curvy. Oh, and by the way, when are you going to get around to paving it? Well, you can't deny that most people prefer paved roads, nor can you blame them. Many even argue that good money shouldn't be wasted on gravel roads because it's like trying to make a silk purse out of a sow's ear. But people's attitudes aside, we're not likely to see most of our gravel roads paved anytime soon. They've been around a long time and are here to stay. Like paved roads, gravel roads should be constructed to minimum design standards and maintained that way as long as possible. They should have a traveled way, a shoulder on each side, and roadside ditches. Their surface should have a modified A-crown, with the travel lanes sloping down from the center of the road for drainage. The surface layer must be strong enough to prevent overstressing the subgrade, stable enough to resist raveling, shoving, rutting, and consolidation within the layer, and smooth and skid-resistant enough for a comfortable, safe ride. Gravel roads are greatly affected by their surroundings, from high mountains to low coastal areas, from cold regions to hot environments, from wetlands to deserts, from hills to flat terrain, and from open countryside to dense forest. But with all this variety in their environments, the most influential factor of all is moisture. A wise old sage once observed that there are 3 keys to maintaining any road: drainage, drainage, and drainage, in that order. Seriously, though, there are 3 important aspects of drainage: getting water off the road, out of the road, and away from the road. Do all three, and you can maintain any gravel road. Getting water off the road is the function of the road's crown and cross-section. A properly sloped surface allows the water to flow off the traveled way, down the shoulders and foreslopes, and into the ditches. Getting or keeping water out of the road is accomplished by maintaining the surface free of flat areas, obstructions, and depressions that will hold water until it weakens the gravel layer and penetrates into the roadbed. Keeping water out is also dependent on building the road at the proper elevation so that it's above the water table. Getting water away from the road is the function of ditches and culverts. Ditches carry the runoff alongside the road until it outlets into culverts, streams, or holding areas. Water, however, is not always an enemy of gravel roads. In fact, in the proper amounts, it's a vital ally, as you'll see in a minute. Perhaps the most important element in the success or failure of any roadway is what it's made of. Material characteristics determine how well and how long the structure will function. Mineral aggregate is the primary component of gravel roads. Crushed stone, gravel, and natural sands are the most common types of aggregate. But with other mineral materials plentiful in many areas of the country, and some areas lacking natural materials altogether, you'll also see slag, shale, chert, crushed basalt, shell, and even some natural soils in use. Not all kinds of gravel are good for road surfacing. Some types break down into fine particles under heavy traffic. Others swell when wet. Still others are so hard they're difficult to work. Good gravel supports the weight of traffic and distributes it enough to protect the subgrade. It remains tightly bound in dry weather to resist dusting and also sheds water in wet weather. Furthermore, good gravel for road surfacing contains a blend of particle sizes. The different sizes packed together, with smaller ones filling the gaps among the bigger ones to form a dense interlocked mass. On the other hand, gravel with particles of all the same size won't pack together into a dense, stable mass, but will remain loose. A good blend of particle sizes is a gradation that ranges from a maximum size of about 20 millimeters down to very small or fine material having the consistency of flour. In fact, the difference between the gradations of good base course gravel and good surfacing gravel is the presence of more of these fines in the surfacing material. Because of it, surfacing gravel is sometimes described as dirty. The fine material serves two essential purposes. First, by filling the voids among the larger or coarse aggregate particles, the fines act as a binder that holds the total gravel mixture together and helps it form a dense, tight mass when the water content is correct and compaction is applied. A measure of this binding ability is called plasticity index, or PI for short. The higher the PI, the better the binding effect. Second, fines are also needed for their crust-forming ability. A hard, tight surface crust on a gravel road bears traffic loads and sheds water. A minute or two ago, it was said that water can be an ally of gravel roads. In fact, to form a hard, tight crust, water is essential. That's because the fines need moisture to turn them into the cement that binds the larger particles together. Another characteristic of good gravel for road surfacing is angular shape. The particles need to be angular, have sharp edges and flat faces to interlock properly. Angular gravel occurs naturally in some areas, or it's a byproduct of manufacturing, such as slag, or it's produced at crushing plants. But in many parts of the country, natural deposits of stone and gravel consist of rounded material. The rounded shapes of such gravel don't allow it to compact and interlock well, even with the presence of sand and fines. Rounded gravel particles act like marbles or ball bearings. Imagine trying to form them into a tight, stable layer. You just can't do it. The control and handling of gravels greatly affect their suitability for surfacing roads. Pit, crusher, stockpiling, and blading operations can either help or hinder the quality. Some examples. At gravel pits like this one, loader operators should remove material from the full face of the pit wall to obtain a complete and uniform blend, not from a narrow band. Crushers need to be set up and operated properly. For one thing, they need to be level. A plant that's out of kilter may segregate the crushed material, that is, separate the particles by size so that the material is not uniformly blended. Also, the screens must be in good shape, not clogged or full of holes. Faulty screens may allow oversized stone in the gravel or interfere with the desired gradation. Stockpiling practices can affect gravel quality too. Start with the basic site. It should allow for proper drainage and be cleared of debris and vegetation so that the gravel isn't contaminated when it's placed there. There should be ample room to place stockpiles of different material without having them intermingle. As much as possible, stockpiles should be built in layers rather than in cone shapes. Cone-shaped piles allow larger gravel particles to run down the steep slopes and segregate from the rest of the material. Removing the gravel from stockpiles is important too. Loader operators should keep their buckets above the bottom of the pile to avoid picking up any base materials such as clay, oversized stones, vegetation, etc. Loader operators can get a better blend of gravel from the ends of stockpiles rather than from the side slopes. This way, material can be taken from the pile's full cross-section. Even during blading, the suitability of the material is affected by the angle and pitch of the grader's moldboard. But more on this later. For now, we'll stop right here. Recognizing the environments in which gravel roads function. Understanding the characteristics of the materials they're made of. And knowing that there are right and wrong ways of working with these materials are a good beginning to dealing with the problems associated with gravel roads. In Part 2, we'll look at those problems, including their causes, prevention, and correction.